I hope you can see the screen now.
Yeah.
Okay. So in the last class, we have finished IP multicast and IP V6 multicast, right?
Mm.
In IP, sorry, not IPv6, IPv4, IPv4 and IPv6 both. So in IPv4 we have PIM and IGMP. In IPv6 we have, what is the second protocol? MLD, right?
Okay. Mm.
Remember,
Yes.
in PIM we have two modes, uh,
Dense and
dense and sparse mode.
sparse.
But we can also configure a combination of sparse and dense mode.
Hybrid. Mm.
Hybrid, yes. Now we are going to start with, quality of service. So if we go through the desktop CCI volume 1, if we open this
Mm.
in CCI volume 1, you can see the first section is, or part 1 is dedicated to LAN switching, which we have covered: Ethernet basics, VLAN trunking and STP, right?
Mm.
Then IP network and IP services. IP addressing, IP services is like, remember,
Yeah.
HSRP, GLBP, VRRP, DHCP, NTP likewise. Then IP IGMP, sorry, IP IGP routing. In IP IGP routing, we have learned about IP forwarding, that how a router will make the decision. We have discussed about process switching, remember,
Mm-hmm.
fast switching, then SEF,
TEL. Mm.
Cisco Express Forwarding. RIP, we haven't discussed this and we haven't covered this. Then we have discussed about AIGRP and OSPF, right?
Mm.
This is what we have in volume 1. Now, if we go to volume 2, likewise, we have few topics in volume 2 as well. So here we go. We have again total 8 sections. So in the first section, we have BGP, which we have covered, right? Right, Ada?
Mm-hmm.
Then after BGP, we have quality of service, which we are going to start. But before that, we have discussed about multicast, right?
Mm.
Do we have covered DMVPN? I think
No.
no, right? Okay.
No.
So now we have to discuss quality of service, DMVPN, not multicast, MPLS. Okay.
Mm.
Yes. Quality of service, DMVPN, multicast. Then we'll talk about SD-WAN controllers, DNA center. All right. This is how we are
Mm.
going to finish our classes. So let's start with quality of service first. Okay, Heather. Now tell me, what do you think about quality of service? Like, what do you mean by quality of service, first of all?
So it will prioritize the traffic on top of the existing network bandwidth.
Mm-hmm.
So it can be anything. Mostly we use this for the voice or video or
Mm-hmm.
any preferred network which we need that the traffic will be highly prioritized. So it will try to load balance between within the let's say the circuit will prioritize that traffic instead of
Yes,
the others.
very good. So basically, quality of service is like QoS means that how define the we can say quality of service is used to define that how a particular IP packet will be created in the network, right?
Mm,
So like we can relate it to our real life as well. Like in real life, we used to call it quality of life, right? For
mm,
quality of life, you need better education, a better job. A better job will give you a better house, better clothes, better food, right? And this thing is going to
yes.
define the quality of life.
Mm,
Likewise, in the networks, we have quality of service. So, for example, if we have a network like this, R1, R2, ISP, PC1, PC2, PC3. All right.
mm,
Now, if the user is sending a packet, we have application layer, we have presentation layer, we have session layer, transport layer, network layer, data link layer, and physical layer. This is how the PC1 will encapsulate the traffic. Then traffic will be given to the router. Likewise, PC2, PC3, they will encapsulate the packets and will give it to the router, right?
mhm,
Once the traffic will reach to the interface. Now on the interfaces, we have type of queues. We have input queues and we have output queues. Likewise here, we have input queues and we have output queues, right?
Mm.
Because you know that if the traffic is coming at the speed of 10 Mbps, it doesn't mean that router will be processing the data at the same time, right? First of all,
Mm.
data will be stored in the queues, then the router will be processing it bit by bit. Using that, traffic will be given to now. By default, when you go to the interface, you will see that there's a queuing strategy which is known as FEFIFO, right?
Mm.
First in, first out.
Out.
This is the default queuing strategy followed by the router Cisco routers. First in, first
First
out.
time.
I'll show you, okay? But that's not a problem. That's not a problem right now here, okay? Because you know that in networks we have types of traffic. In types of traffic, like we have text data, right? We have voice data. We can have video form data, right? Like .text file, .mp4, .mp3, audio file, or you can say voice data, right, Adam?
Mm.
If you're sending an email, so email is what? Email is text data. If you are on a call, what is a call? Call is a voice data, right? If you're watching a
Mm.
video on YouTube, so YouTube is what? Voice plus video. Yes or no?
Yes.
Voice plus video.
Video.
In the initial days, that was not a problem because you know that if inside a company, if I'm using a phone, right? If this PC1 is having a phone, PC2 is also having a landline phone. PC2 is having also a landline phone, right?
Mm.
Now this landline phone is having what? This landline phone is having a dedicated line, right? They are not part of our network because you know that in the past we have a landline phone, right? Landline phone is having a
Mm.
completely separate line or completely separate media. So you are calling through this phone. So you are sending the voice data on the landline, right?
Mm-hmm.
You are sending the mail over the network. Likewise, you are sending the voice data on the landline phone. You are sending the voice data on the landline phone, right? So we are having a separate medium for different type of traffic. Yes or no?
Yes.
Now, have you heard a term known as VoIP? VoIP,
VoIP. Yes. Voice over IP.
voice over. What is this?
So
It
it's
means that you don't need a separate
converting into
landline, right?
digital. Yeah.
You can use your IP network to send voice data as well. You can use your same network, IP network to send the voice traffic. That's why you will see that Cisco is having a dedicated stream for this voice and collaboration, right?
Mm-hmm.
So what we are learning in voice, we are like how we operate an IP phone. Have you seen our IP phone? Cisco is also in
Yes.
this market, right? Cisco is also building
Yeah.
IP phones. If I show you Cisco IP phone, this is Cisco IP phone, which can be connected to a network. All right.
Mm-hmm.
And this is a PoE device. What is this? This is a PoE device.
Device.
So this is Cisco IP phone.
Yes.
So now we have IP phone connected in the network and we have desktop connected in the network. So voice over IP, or you can say your IP phone will be sending the voice data. My laptop is
Mm-hmm.
sending some other data, right? But the underlying media, the underlying network is same. Underlying network is same.
Same.
Now we have few properties of the link. For example, we have a media here. For example, this is my router R1. This is my router R2. A link is connected between them. Router 1, router 2. And here is a network and we have a user here, right? And there is a word known as latency, or we call it delay as well, right?
Mm-hmm.
What is latency or what is delay? What do you think, Adam? What is latency or what is delay?
So it's so kind of a similar, but
Yes,
delay is when the packet arrives on a certain, like, should be arriving instantly, but whatever the uh, how long it can be trailing in, or that can be a delayed, right? So
yes. All right. So basically, if you're sending an IP packet from here, that packet will go to switch, switch will give it to router. Now this media
mhm.
will add some latency, right?
Yes.
Then the traffic will go to the router. Now router will take forwarding decision. So router is not like a hub that it will receive the electronic signals and it will pass the signals. No, router will receive the signals, it will inspect the signals, then it will take the forwarding decision. So this process is also going to take some time. Then traffic will be forwarded to router 2. So this media is also having some delay, right? Then the traffic
Mm-hmm.
will be given to user. Again, adding more delay. So you can see more number of hops means more number of delay. Longer the path, longer the delay, right?
Mm.
Now there are few terms like latency, delay. There's one more term which is known as jitter. We'll talk about them. What is latency? What is delay? What is jitter? First of all, let's have an introduction of quality of service. Okay, it is directly moving to the topic. All right, no issue. I'll give you the introduction, and you already know this. So you can see the goal of qualification and marking tools is to simplify the classification process of other quality of service tools by performing complicated classification steps. All right. They haven't given us the introduction. Now, all right, no issue. So basically, what is quality of service is QoS is used to define that how a particular IP packet will be treated in the network, right? We have
Mm.
the quality of service at two layers, layer 2 and layer 3. You'll say, what about layer 4? See, layer 4 is never used to take the forwarding decision. Yes or no?
Yes.
What we have at the layer 4? We have at the layer 4, we have TCP or UDP. And in TCP or UDP, what we have? We have the port numbers. We have the port numbers.
Number.
So most of the time we are using layer 3 and layer 2 to make the forwarding decision. Router is using layer 3, switch is using layer
Mm-hmm.
2, right?
Two.
So
Mm.
both of the layers are providing functionality of quality of service, and which is a technique to prioritize the traffic. A technique to prioritize the traffic.
Traffic.
Mm, 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 mm. Now, by configuring QoS, a particular type of traffic can be prioritized or other types of traffic. Layer 2 and layer 3 headers are having dedicated fields to configure quality of service, right?
Mm.
We have latency critical traffic, which can lose its meaning if because of high latency, right?
Mm.
Like I'm talking about voice and video traffic. Most we call them live traffic as well, right? Voice and video is live traffic as well. I'm not talking about the recorded video or the live streaming. I'm talking about the basic nature of the voice and video traffic, right? So voice and video
Mm.
traffic is what? Voice and video traffic is kind of live traffic. So it is in the continuous form, right? If there is a 5 minutes video, you'll be receiving from second by second, right? Voice and video traffic. So now, if we come back to the latency, come back to the delay and jitter. So if you need the definition exactly, so we can say latency in computers, networks. Okay. So network latency is the same as delay.
Mm.
Network latency is same as the delay,
delay.
right? So what is network latency? Network latency is the delay in network communication. It shows that data takes to transfer across the network. It shows the time that data takes to transfer across the network. And we have also SRTT timer is calculated, right? What is SRTT timer? Smooth, round,
Mm.
trip, timer. Like this is user 1, this is router, this is router 2, and we have one more user here. So if the traffic is going from here, 1 millisecond delay is here, 1 millisecond delay is here, 1 millisecond delay is here. So it will take total 3 milliseconds to reach the destination, right?
Mm.
When the traffic will come back, you can say reply 1 milliseconds, 1 milliseconds, and 1 milliseconds. So total 6 milliseconds. Now what is 6 milliseconds? 6 milliseconds is what? 6 milliseconds is SRTT timer, smooth round trip timer. Time taken by a packet to reach the destination and what a response, right?
Mm.
Networks with a longer delay or lag have high latency, while those with fast responses time have low latency. Networks with a longer delay. Now, what can cause delay? Higher amount of traffic, right?
Mm.
High amount of traffic can also add delay, and delay can lead to the latency. Yes or no?
Yes.
Because if you remember from the switching thing, we have the access layer. This is my access 1 switch. This is my access 2 switch, access layer switch 2. This is my distribution 1. This is my distribution 2. This is the topology. We have individual users here. So in this case, you know that the user is connected to a dedicated link, right? But when it comes to the access layer switch, they're going to have the same link to forward the traffic. Yes or no?
Yes.
If you're not using link bundling, then one of the link will be in the blocking state. So if I suppose that this is my interface in the forwarding state. So 1, 2, 3, 4, 5, 6. For 6 of the users, this is what? This is shared link, right?
Mm.
And you know that in every switch we have few ports which are high bandwidth ports and also known as uplinks, right?
Uplinks.
If these
Yep.
are fast ethernet, you'll see that the switch also having gigabit ethernet link also for the uplinks, because a gigabit ethernet means 1000 mbps and fast ethernet means 100 mbps. So by increasing the bandwidth we can reduce the delay, right?
Mm.
Because you'll have the free media, so you can forward the traffic. So now if you have 20 users here and you have 1000 mbps link here, so 1000 upon 20, sorry, not 10,000, 1000 upon 20. So like we have 50 mbps, right, per user.
Mm.
But you know that you cannot utilize the full. So for example, you have 40 mbps per user. But if you are using a 100 mbps link as an uplink, 100 is the highest speed. You have 20 users around. 3 to 4 Mbps. Per user, you'll get the speed of 3 to 4 Mbps, right? So instead of using the same interface as an uplink, we are using higher speed links or higher bandwidth links as an uplink, right?
Hmm.
Just to reduce the latency. So you can read here, network with a longer delay or lag have high latency, while those with fast responses times have low
Low latency.
latency. CMD, ping www.google.com. Packet sends, packets sent 4, received 4, lost 0%, right?
Hmm.
You can see approximate round trip times in milliseconds. Round trip time. You can call it RTT or you can call it SRTT, smooth round trip timer. So what it is saying that from my machine to send the ICMP packet to Google server and get back a response. What is the time? 7 seconds, right? So the maximum was, either maximum was 7
7
milliseconds and minimum was
5.
5. So they have calculated an average, which is around 6 milli. So if we calculate one way, so it is around 3 milliseconds, right?
Hmm.
If I ping it again, 5757. Basically, in my network, we don't have any load here. Ping www.netflix.com. Request timeout. I think Netflix is blocked here. Mm, Amazon.com. Again, approximate 6 milliseconds, 5 milliseconds, right? 6, 6, 3, 3. So you can see the average time is 4 milliseconds, right?
Hmm.
So the latency or the delay is keep varying, right? It depends on the load on the media. And it also depends on your mediated devices like switches, routers, right?
Hmm.
So delay and latency is the same thing. What is jitter here?
So jitter, I believe, if I remember, kind of a error or
Or you can say jitter is a kind of a difference.
okay.
Okay. For example, first is I'm talking about only one side time. So 3 milliseconds. Second is 3 milliseconds. Third packet is also taking. Fourth packet is taking 5 milliseconds. All
Hmm.
right. The difference is around, you can say, 2 milliseconds here. This thing is known as
Jitter.
jitter. And if we go to search for the definition, so you can read it here. Jitter is what?
It's a variation in time delay between
Between
when a signal is transmitted and when it is received over a network connection, measuring the variability in ping. This is often caused by network congestion, poor hardware performance, and not implementing packet prioritization.
So you'll see the differences in the packet timer, right? So this thing is known as jitter. This thing
Mm,
is known as jitter in the network. All right.
mm,
All right. Is the variation in the latency on a packet flow between two systems when some packet take locals to travel from one system to other. Jitter result from network congestion, timing drift, and route changes. Right?
mm,
You can see the jitter and latency both at the same time. Jitter and latency are the metrics used to assess the network performance. The major distinction between jitter and latency is that latency is defined as a delay by the network, whereas jitter is defined as the change in the amount of latency. Change in the amount of the
latency.
latency. Here's a visual representation that illustrates what's happening behind the scenes. When packets arrive at unexpected times, voice over IP calls can be interrupted, right? Steady flow of packets, same stream after congestion or improper queuing. So you can see the difference here.
Mm,
Okay. So this adds up the latency, and latency can, change the experience. All right. Any difference here now in jitter or latency?
no.
Most of the time it is caused by the bandwidth or the media load, right? And the poor hardware performance. And you remember that CEF, right? Cisco Express Forwarding. That why we come up with the CEF? Because in process switching and fast switching, all the traffic was going through the CPU processes, right?
Mm,
And it was adding more latency to the traffic. So that's why we come up with the CEF, Cisco Express Forwarding, that you don't need to forward all the traffic through CPU processes. You can forward it directly, right? And you
mm.
can reduce the latency over there. Any confusion here? Either? No. Okay. So that's why now we understand what is latency, right?
Mm,
Now we also understand latency critical traffic. Latency critical means like if you are sending mail, to someone, right? You have written the header, subject, right, and the content. Then at the last, you can say footer or the thanks and regards, right? So written down everything. This is a mail. What kind of message this? This is text message, right? At the end of the day, what we have in the mail, we have the right other.
Text message, yes.
On the other hand, if you are doing what? If you're on a video call, in video call we have two types of data. We have video and we have voice. So like right now we are on a Zoom call. So what is this? This is a video plus voice call, right? Video data plus we have
Voice.
voice data. Video data plus
Voice data.
voice data.
Hmm.
So video data and voice data should be delivered immediately. We can't keep the voice data and video data in the queues. We can't keep the voice data and video data in the queues. All
Yes.
right. We have
Hmm.
to forward it immediately because you know that if there would be latency in the voice and video data, it can cause bad can cause the bad experience, right? It can cause the bad experience. Now you will say that who is responsible for this? Who is responsible? You can't blame only on the network, okay? All right. It can be the problem in an application. There are higher chances, right?
Hmm.
For example, if I am having two video calls, one is on Zoom and second is on Google Meet. If my Zoom is working, not sorry, Zoom is not working, I'm lagging here, I'm getting a lag, and Google Meet is working perfectly fine. So
Yes.
whom you will blame? Network? No. Google Meet is working fine. We are not getting any latency over the video as well as the voice. But
Hmm.
once I'll start using Zoom, we are getting start getting lag in the voice as well as in the video. So it's not only the problem in the network itself, right?
Yeah.
It's also the problem with the application as well, because it depends on the application. Like if I record a video using Camtasia, same video is around 1.5
1 GB. Uh,
GB or 2 GB, right?
correct.
But if I record the video using Zoom recorder, video is recorded in the like around 300 MB,
500. Huh?
400 MB,
Mm-hmm.
right? So it also depends here. Likewise in the network, if you're getting latency, then there could be the problem with the application itself. If the application is fine, application is working great, then the problem with the network, right?
Mm.
So we have to look, or we have to check the like every aspect of the network. So what we need here, we have latency critical traffic, because if you will keep voice and video data in the queues, it can add more latency. More latency will lead to a bad experience, right?
Mm-hmm.
More latency means bad experience. So
Correct.
what we have to do, we have to say that we need to provide quality of service, or we need to prioritize voice and video data. You will see that, is it always the video and voice data is prioritized? No, it totally depends on the end customer. Total depends on the end customer, right?
Mm-hmm.
Like for example, it is the initial days, for example, and this is Amazon company, right? What Jeff Bezos did, Jeff Bezos hosted the website on its local servers, right? In its garage. So this is server 1, this is server 2, this is a switch, then they have a router. For example, they have a firewall as well, and then they have an ISP, right? And he's also using his desktop and an IP phone, right? The
Mm-hmm.
user are browsing, or user are requesting for the www.amazon.com. And what Jeff Bezos is doing? Jeff Bezos is talking on mobile phone with someone, not the business call. It's just doing time pass,
Mm-hmm.
right? Right, Heather?
Mm-hmm.
So the voice is generating the, or IP phone is generating the voice. Just 1 second. Heather. Give me 1 second, okay?
Okay.
हेलो, हाँ जी सर, ऑफिस में मैं आ गया, आप वहीं रुकोगे अभी? तो पूछ रहा हूँ, मतलब फ्लैट पे रुकोगे या जाओगे? कितनी देर में? अच्छा, ठीक है, आ जाओ फिर, ऑफिस आ जाओ. Yes, hello.
Yes.
Yeah. So the user is trying to access the www.amazon website, right?
Mm-hmm.
In this case, you can see IP phone is generating voice data, right? He's
Mm.
also watching a video. So the desktop is generating voice and video data. But if we think about it, which one is important data? The website data or voice and video data?
Wife.
Website, right? Because if
Mm-hmm.
website is slow, then the user will have a bad experience. The users has, they don't care about the voice and video which is inside, but voice and video are using the same media as the website data, because the server are hosted on the local network, right?
Yes.
So what we need to do in this case? In this case, we need to prioritize which data? website data. It is
Mm.
images, right, plus text. Images plus text, right?
Yes.
So it depends. It depends on the business to business. It depends on the company. What is the important data? All right. Can be voice and video. For example, there is a BPO who is giving or he is providing the services on the call, right? For them, voice is the important data. For example, I'm calling to a customer care, like my SIM card is not working or my SIM card is having some problem. So I'll make a call to the customer support, right?
Mm-hmm.
So what the people are doing? They are providing the support over the voice call. Yes or no?
Yes.
So for them, which is what is the important data? Voice data,
Mm.
right? Because they are giving the support over the voice traffic. So it depends network to network. It depends on the requirement, which is the critical traffic for us. But if we have a mixed environment, in that mixed environment, and if the both types of data is important, so we have voice and video, which is more critical, right? Because if you'll add latency to the voice and video traffic, it can ruin the experience, or it can leave a bad impact, right, Heather?
Yes.
So we need to prioritize the things here. Now we understand the requirement that okay, we have a few types of traffic in the network. We are using the same media, we are using the same network devices, but few of the network traffic is latency critical. So it means by adding more latency, it can ruin the experience. But the question is how? How we will provide the prioritization? How we will configure the prioritization? How I'll tell my how I'll configure my routers and switches in such a way so that they send the voice traffic prior to any other traffic, right?
Mm.
So challenge is in front of us. That's not a concern. But the question is how? How we will do it?
So we'll tag it. We'll tag the traffic that this is
Yes.
a.
So the first step towards this is classification, right?
Mhm.
Second is marking. Third is implementation. So first of all, we are going to classify the traffic, that this traffic should be prioritized, right? After the
Mm.
classification, we will mark that traffic, and then after marking, we will implement everything, which is going to prioritize that particular traffic. Which is going to prioritize the particular traffic, right? Now, in the network, we have devices like we have router, we have switches, we have firewall, we have access points, right?
Mhm.
Which are going to be in the transit path. Like router is going to be in the transit path. The packet is going from network A to network B. There should be a router in between. There must be a switch, a firewall, an access point if you're connected through the wireless network, right?
Mm.
So now if we think about a network, or if we think about a router, this is a router. The traffic is received on the router. What router will do? Just a second. Hello. I'll be back in 2 minutes. Okay. Hello.
Yes.
I'll be back in 2 minutes.
Okay, okay, no problem. Take it.
When the user will send traffic to the router, the user will add the headers again, application headers, then presentation session, transport layer, then it will add a network layer header, then data link layer header and physical layer header, right?
Mm.
And the router is having what? Next interface, which is connected to another router. So this is F0/0. This is F0/1. When the traffic will come first on the router, it will hit on the F0/0 interface, right?
Mm.
Now F0/0 interface will receive the traffic in which queues? Ingress queues,
Yes.
right? After receiving the traffic, what R1 will do? R1 will give traffic to the further processing, and the further processing will remove the physical header, then they'll remove the data link layer, data link layer header. After this, router will take a lookup in the network layer, right? In the network
Mm.
layer, router will see that source IP and destination IP. Now what router will do? Router will make forwarding decision. Router will make forwarding
Forwarding.
decision. Now F0/1 is having two queues, right?
Mm-hmm.
Egress queue and ingress queue. Ingress queue means for the incoming traffic, and egress queues means for the outgoing traffic. If the traffic is coming on R1 interface F0/0, in which queues? Ingress queues. And as per the routing table, if exit interface is F0/1, right? So the traffic
Mm.
will be given to egress queues of F0/1. Yes or no?
Yes.
The traffic received on the ingress queues of F0/0 will be copied to the egress queues of F0/1, and then the router will forward that traffic to R2. So the router is going to take the forwarding decision on the basis of IP header, right?
Mm.
When it comes to a switch, most of the time switch is taking forwarding decision on the basis of Ethernet header.
Header.
Firewall is also taking the decision on the basis of IP header, and it also depends on the deployment of the firewall, because you can deploy firewall in two modes, layer 3 mode and layer 2 modes. And if you have deployed the firewall in layer 2 modes, it is known as transparent firewall. Okay,
Mm.
so it depends. It depends on the firewall deployment, if it is deployed as layer 2 or as a layer 3. Then we have access point. So on access point, you can configure wireless quality of service. Firewall switch routers, we are going to configure wired quality of service. Okay.
Mm.
And you know the easiest is in access point, because in access point there is no like classes, marking, nothing. They have four classes. Okay.
Mm.
First class is platinum, gold, silver, and bronze. And the preference criteria is top to bottom. Okay. So you have to define a traffic to the class. You can define it to platinum class, gold or silver or bronze. Okay. But now, first of all, we will be discussing about the quality of service in wired network. And when we'll talk about the marking values, class of service, type of service, differentiated service code point. All right. So we'll say there are different types of values to mark the traffic. We'll talk about it right now. But in case of wireless, we have profiles like platinum, gold, silver, and bronze. All right.
Yes.
Now, if we talk about IP header, either it is IP version 4 or IP version 6. But if first of all we talk about IP version 4 header, in IP version 4 header we have few fields. Okay, version, header, length, okay, TOS, and total length. All right, Heather. Then we have identification. We have flags here. In flags we have MF, more fragment. When we have reserved flag, and we have don't fragment, DF. Here we have fragment offset. Okay. Then we have time to live, protocol number, and checksum. Okay. Then we have source IP address, and we have destination IP address, and then the last we have options and padding. Okay. This is the IP header. So in this IP header, we have a dedicated field which is known as TOS. All right. So the length of the TOS is 1 byte, or you can say 8 bits. So the length is 1 byte. All right. First of all, TOS stands for type of service. TOS stands for type of service. And if you talk about, Ethernet header, so you have two types of Ethernet header. First is without, dot 1Q, right? So without dot 1Q, we have preamble, SFT. Then we have destination MAC, source MAC, type field, and CRs, cyclic redundancy check, or you can see again section. Okay. So here don't have any quality of service field. But when you configure trunking, right? So you configure trunking and trunking encapsulation. Ethernet plus .1q header. Remember .1q header.
Yes.
.1q is
Like
used at the time of trunking for marking or for the tagging of the VLAN ID.
correct.
Okay. And you know that .1q will be added somewhere in between. Let me use a different color for this. So then .1q will be added with the Ethernet header. Okay.
Mm.
Normally the size of Ethernet header is 18 bytes, but when you configure .1q, it goes up to 22 bytes. Now .1q header is of how long? 2 bytes. All right, Heather.
Mm.
In .1q header, you have two fields. First is known as tag protocol identifier. Second is known as tag control information. Okay,
Mm.
TPI and TCI. Now, sorry for this, it's not 2 bytes, 4 bytes. Okay, out of 4
Okay.
bytes, TPI field is for 2 bytes and 2 bytes for TCI, tag control information. Okay, now in this we have 12 bits for tagging. Okay,
Mm.
3 bits are for and 1 bit is reserved. 1 bit is
Reason.
reserved. Now, what is CoS? CoS stands for class of,
Service.
which is again used for traffic prioritization. So the native 802, native Ethernet header is not having any field for quality of service. Okay,
Mm.
but once you configure a trunk and you configure ISL or .1q, nowadays only .1q is supported. So .1q header will be added with the Ethernet header, and in .1q header we have 3 bits for class of service, or for you can say for marking. Okay,
Mm.
now IP header and Ethernet header, both of them are supporting field for the marking, and on the behalf of that marking, a router will prioritize the traffic. It's clear now.
Mm.
If we come back to the IP header, in IP header we have what we have right now. We have TOS, right? Type of service. We have type of service. 1 byte. 1 byte means how many bits are there? In one
8.
byte, 8 bits.
8 bits.
1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, 8. Right? Now you have total
Mm.
8 bits. In the previous days, not nowadays, I'm not talking about today's network. Okay. In the initial days, when TOS was added to the IP header, in TOS we have total 8 bits, right? Out of 8 bits, we are only using How many bits are there?
3.
3 bits. And this is known as IP precedence. Okay,
Mm.
this is known as IP precedence.
Precedence.
And these 5 remaining bits are unused. Okay,
Okay.
but things has been changed now. We'll talk about DSCP after this. Then you'll see that we are using all of the bits now. Okay.
Mm.
So in the initial days, we were only using first 3 bits, which is known as IP precedence. This is known as IP
Precedence.
precedence. Now, how many bits do you have here? 3 bits. So out of 3 bits, you can have total 8 values for the marking, right?
Mm.
0, 0, 0, 0, 0, 1, 0, 1, 0. Then other after 0, 1, 0, 0, 1, 1,
1.
1, 0, 0, 1, 0, 1,
1.
1, 1, 0, and 1, 1, 1,
1.
right?
Yes.
So now we have total 8 values for the marking by using 3 bits. Now we have given name to them just to remember things. So this is known as routine. Okay. This is known as priority, immediate, class, class, override,
Mm.
critical, internetwork, and network. Okay. So we just have given the name, but you know that the routers, switches, devices are not going to understand the name. They're just going to understand the binary values, 0 and 1, right?
Mm.
This is the preference criteria. Low,
Yes.
high. Okay. 0, 0, 0 is will be getting lower preference in comparison of 1, 1, 1. So 1, 1, 1 will get the higher preference. Same thing applies to QoS. Okay.
Mm.
So the same thing is applied to class of service. Okay,
Hmm.
now by default, so same thing will you will have in the course. All right.
Hmm.
Now, if this is R1, this is R2, and if I have configured OSPF between them, right? So the OSPF is the most important traffic. Okay.
Hmm.
You'll say, what about voice traffic? What about video traffic? See, can you forward voice and video traffic without routing?
No.
No. Then who is most important? OSPF, of course, yes.
Routing this.
So when you'll configure OSPF for EIGRP, let me see if VMware is on. Yes, AV is on 192.168.125. Sign in, close lab, for example, BGP. Let's remove this and start all nodes. Now we have two routers, VIOS1 and VIOS2. We'll configure OSPF on the router, and then I'll show you the default marking, which I haven't configured yet, right? Which is
Hmm.
inbuilt, which is by default, and you can't change it. So VIOS1 and VIOS2. Okay, so the routers will boot and then we'll see the default behavior. Yes. No. And no. So now first of all, we'll configure IP address on VIOS 1. Enable configuration mode, hostname R1, interface gigabit 0/0, IP address, for example, 12.1.1.1/24. VIOS 2. Enable configuration mode, hostname R2, interface gigabit 0/0, no shutdown. Show IP interface brief, exclude unassigned. Now, after this, I'll go to R1 and I'll configure OSPF here. Router OSPF1. What I'll say network 0.0.0, area 0. When you'll configure OSPF here, R1 will start sending hello message. So if we go to the Wireshark, we can see the OSPF hello message, right? Source IP is 12.1, destination IP is 224.0.0.5. Open shortest path first. If I open the IP header, in the IP header, now you can see differentiated service code point. As I've already told you that things has been changed. First, we were using IP precedence in old operating system. Nowadays, we are using DSCP, differentiated service code point. Okay. But still you can see the values because it is backward compatible. So how many bits are there? 1, 2, 3, 4, 5, 6, 7, 8. If I write them down, 1, 1, 0, 0, 0, 0, 0, 0. These are total 8 bits, right? In IP precedence, we are only using 3 of them and 5 are unused. Yes or no, Heather?
Yes.
What is the placement of first 3 bits? 1, 1, 0. So if we see here 1, 1, 0, right? 110 is for
Internet.
inter-network. I haven't done this. I haven't changed anything. I have just configured OSPF and this is the default behavior. But if I send the ping packets, if I ping from VIOS 1 to VIOS 2, ping 12.1.1.2. Ping is successful, right? Echo ping request. ICMP packet, you can see the fields value 0.0.0.0.0.0.0. We are not using the last 5 bits in IP precedence. These are unused. We are only using first 3, right? And what is the value of first 3? 0.0.0. 0.0.0.0 means routine traffic. This traffic.
Correct. Routine traffic.
Because what is ICMP? ICMP ping is just a routine traffic, right? We are not going to prioritize ping traffic. Yes or no?
Yes.
Yeah. Any confusion here?
No.
No. Okay. So this is the default behavior of IP precedence and everything. All right.
Mm.
In the next session, what we will do, we'll compare IP precedence with DSCP. Then we'll see the marking values. We'll see the quality of service models like best effort delivery. Then we have diff serve. Then we have int serve. Okay. So we have
Okay.
models for the quality of service. We'll explore them tomorrow. That's all for
Right.
today, Heather. If you have any confusion, please feel free to ask.
No, I'm good.
Good.
Yes.
Okay. So have a good night and see you tomorrow.
Thank you.
Okay. Bye bye.